All right, now that I've unmuted my microphone, here's this sample project again. So I decided to do my sample project on the different things and factors that might be associated with Exam 3 scores. Exam 3 is important to me because it's inferential statistics. This is where we get our first look at how statistics are usually used when they're used to make decisions that affect us in our lives. So p-values, hypothesis testing, confidence intervals, all of these are at the heart of how we use stats in decision making. So you can see here at the bottom I have a quote. I forgot to put a quotation mark at the beginning from an article from the Journal of Stats Education on just the importance of understanding inferential statistics at a deeper level than just procedural. I'm not going to read this quote to you, as I do not want to see people reading slides to me in their presentations, because we are all capable of reading ourselves. So try to keep your bullet points very terse, and then talk about them rather than read them. You should have less information rather than more on the slide. If you want a big quote from an article or something, go for it. No reason to give links to your articles. You've already gotten credit for submitting those, so if they're not adding a whole lot to your presentation, just don't mention them. Just talk about your purpose and move on. All right, in order to collect my data, I took a convenient sample. I have 3 statistics classes this fall. 2 of those are Math 119X, and 1 is a hybrid Math 119, so we meet once a week instead of twice a week. And I used them and their data as my sample. Technically, it's almost like a census, but if I'm saying it's a census, then I don't really have inferential statistics to make in terms of a population. So I'm going to try to use this sample to sort of say some things about all 119X and 119 classes, or all of my classes in general. The color of the exam was assigned somewhat randomly. I say somewhat because one of the biggest issues is I do every other, so that way nobody is next to somebody with the same exam color. And so that's not truly random, as it would be as if I flipped a coin and then assigned whether you got a yellow or a green test. Some limitations: obviously this is only from one professor. However, I personally am only interested in myself as a population because that's the only thing I can truly impact. But it is a single semester, and the biggest issue here is within this single semester, the 119X is a pilot. This is our first time ever teaching this class, trying to figure out what it's going to be, what it should look like, how we support students who may not have the same incoming algebra skills be successful in a transfer level math course. So that's a big compounding variable, is the fact that this is a brand new course for the first time ever that we're teaching it. Another confounding variable or issue here is that my 119 is a hybrid. And so hybrid adds its own challenges. Our online and hybrid classes tend to have lower success rates than traditional classes. That's just true across the board, whatever subject you're talking about. There was something else I just thought about. Oh, another issue that's not even on the slide is that waiting till exam 3 to sort of analyze this stuff, I've lost a lot of students already, as we're going to see in a future slide. So we're not truly looking at all the people who originally signed up for my 119 courses, because we're left with who's still in the course at this point. And then another caveat to throw into that random assignment of colors, I like to let students feel like they have some sort of control. So if the student wasn't sitting directly next to someone, I usually asked them what color they wanted rather than assigning them a color. And so students in the last row and those who arrived late, I generally let choose their exam color, and most of them chose yellow instead of green. So just another way of me ruining my own experiment by not randomly assigning those people, which is a limitation. Just to summarize what my data looked like, I had a number of variables. I had scores for the first 3 exams, as well as attendance. Attendance, I'm not entirely sure how Canvas decides on this, but this is based on when I click your face and say you're here in attendance in Canvas. As you can see, the exam scores had very wide ranges. For most of the exams, we went from like a 20% up to over 100. Students did almost perfectly. For all three of the exams, there was a slight left skew, as I usually find. And if you look at this, we can actually see that on both the mean and the median, our exam scores decreased as the content got harder. So that's normally something I see, is that as the content becomes more challenging, the average exam scores are lower. But usually this is sort of buoyed by the fact that many of the students who were not studying well will have dropped the course, so normally it sort of averages out and they all end up pretty similar. This is the first semester that I've seen this big of a drop-off, especially in the averages and medians going into exam 3, just as a note. A little bit of a summary of those categorical variables I had. I did also rewrite these exam scores as letter grades. If you look at the letter grades, 54% of students failed exam 3. The numbers next to those is how many students were in each of those grade categories. So you can see it almost looks like a nice unimodal thing until you get to the Fs, and then not so much. The proportion of greens and yellows in males and females were pretty even across the board. And then you can see the breakdown by different classes, which again were pretty even. I will make one note about this table here at the bottom. For the hybrid class especially, I started with 46 students in the hybrid versus, maybe not 46, but close to the actual class cap, whereas the two 119Xs were capped at 36 students. So I've had a lot more students drop the hybrid class, which is typical for an online class, which is part of the reason why online classes tend to have lower success rates in general. So the first relationship I explored was the color of the test versus exam score, because usually I have two versions, and this time I didn't. I had the same test, just in different colors. And I tried to do that random assignment-ish when I was giving out the tests. And you can see here I did a box plot to investigate this relationship. And in the box plot, we can see the median for the yellow test was under 60, while the median for the green test was over 70. So there's already a big difference in the medians. And as we glance more at these box plots, we can see in general for every single measure in the 5-number summary, the green test is higher, right? The entire box is shifted up as well as the max and the min. So it's looking like there might be something going on, and I'm curious to know if it's a statistically significant difference. So in order to investigate that, I ran a one-way ANOVA. So my one-way ANOVA does have some assumptions to be met. The harder of the two to meet, I actually did have. The equal variances, if we go back here, the standard deviations were fairly similar. I ran that test that you can in StatCrunch and got a large p-value, so there's nothing here to say these variances are not equal, so I have equal variances. I ran QQ plots. I'm not going to show them to you because they're boring, but both of these were fairly normally distributed. So normality-wise and equal variances-wise, I was good. The biggest place that I ran into trouble with my analysis of variance assumptions is the independence within the groups and the independence across the groups. I'm going to have issues because since I did this sort of cluster sample, if you want to call it that, where I looked at every student in a class, in these 3 different classes, those classes have a dependency, which is already one sort of issue. Additionally, across the groups, I gave the yellow and green along a row, so people who were sitting next to each other ended up with different test colors, and those people tended to be somewhat similar, the people who they sit next to, right? Even in one of my X classes, I have twins, and so they sit next to each other, so they obviously each got a yellow and then a green. So I'm kind of failing at that independence across groups because of the every other situation of people sitting in rows with their friends and near the people that they study with. But ignoring all that, I still ran analysis of variance, ANOVA, and I got a p-value of 0.093. So I can reject the null, and I can conclude with that there's statistical evidence that there is a difference in the average exam score between the yellow test and the green test, right? So that's what ANOVA talks about, is this average, and my quantitative variable was exam 3, so the average exam 3 score was not the same for those different categories, in this case the red and the yellow forms of the test. And if we went back to this, we can actually note that, oops, the green test was much higher performing, right? It had a higher average. I can't say that from the ANOVA output, but I can say that by looking at the actual box plot and means. It appears that the green test had a higher average score, and moving forward, maybe I should only offer green tests. All right, so the next thing I looked at was whether or not class type affected the letter grade of exam 3 score. So now I'm looking at 2 categorical variables. So to look at this, I did a stacked bar chart. For my stacked bar chart, you can see the D's and F's are the yellow and purple. So the yellow and purple section is much smaller in the 119 than it is in the 119X. So it looks like maybe the 119 performed a little bit better. If we dive in a little bit more, though, you can see that the 119X had a higher proportion of A's. Their blue section is bigger. So definitely more extremes in that 119X than there were in the 119. I also provided a table here just in case people were interested, where you could see the breakdown by the percent. So the F's were exactly the same. There were more proportionally D's in the 119X, or there were more proportionally C's in the 119 and B's. So the sort of middle of the road passing was higher in the 119s, whereas, as I pointed out, the A's and D's were higher in the 119X's. So in order to see if this was statistically significant, these differences, I ran a chi-square test. Before I get there, let me just talk about the assumptions. One, we need a simple random sample, which, as we talked about before, I don't really have. So that's a problem. And the other thing I needed was expected counts of at least 5, and I didn't have that. Some of these categories were very small, especially the A's for both classes and the D's for the 119. So I didn't actually have those expected counts greater than or equal to 5. So unfortunately, my assumptions weren't met, but I'm going to continue anyways. The p-value for my chi-squared was humongous. So there really wasn't enough evidence to show that there was a relationship between the type of class and the letter grade on exam 3. Because I'm extra, I was curious to know if the little proportions of D's and F's, this difference here, was enough to be statistically significant. So I ran another chi-squared test of just pass versus fail for the 2 classes, and still didn't have a statistically significant relationship between the classes and whether people passed or failed the test. So to conclude, I looked at different things that affected exam 3 score. For your projects, you might not just look at one response, you might have multiple, and that's fine. The factors that I found that had a statistically significant impact on exam 3 score, relationship with exam 3 score, were the exam color. The previous exam scores, those had p-values of less than 0.001. They were highly statistically significant. And the higher you scored on one exam, the higher you were the higher your exam 3 score was predicted to be. So typically those had a positive linear relationship, which is not surprising. Attendance was only significant at a 10% level, but again, it was the more you attend, the higher your exam 3 score was predicted to be. Factors that I did not have a statistically significant relationship that we failed to reject the null with were gender, what type of class it was, what time the class it was, the class in general seemed to have no impact on exam 3 scores, which is good news for the 119X, I believe. In terms of future work, it would be lovely if I could expand this beyond just me. That would be good. I would love to be able to break things down by question type, especially to see if there was a certain question that helped predict whether or not students were going to pass the test. Is it that students are doing better or worse on multiple choice versus free response? Is it what about the warm and fuzzy, right? I told you what the warm and fuzzy was, so that should be a good predictor of exam score. I'd be very curious to know the warm and fuzzy versus the actual exam score, because sometimes when I grade that first page and a student can't do the first question that I said was going to be on the exam, I know it's going to go downhill from there. I wish I had done better random assignment of exam colors, maybe assigning seats randomly as people walked in, so that way I truly had a random experiment and could actually say that the green exam did something. And then maybe expanding exam colors, especially if yellow ends up being bad. Maybe is blue just as good as green? How can I have multiple colors where one's not going to negatively impact students?